Testing, testing. Alright, looks like I've got one or two viewers so far. So, what's going on right now is trying to figure out why some of these probes are performing worse than others. Okay, so let's look at one of these failed ones. So we've got A69018. That is S11. We want to see S21. Okay, so this is A69018. And that was A69018. So this one looks to... Alright, so this one is just barely failing. If we jump back to the S parameter view here, we can see it's just grazing 23.5 dB down there. So this is barely a fail. And the question is, what is different about this one versus some of the good ones? So just looking at it at a glance, from the side I see it looks like the connector is kind of lifted up a little bit. It's not as flush with the PCB as I'd like. So there's quite a bit of solder under the SMA on that side. Actually on both of them. So it looks like the connector's kind of a little bit skewed like that. Yeah, so it should be sitting parallel at the board. It's kind of tipped. So that could be part of it. Looking more in at there is a fair bit of solder on the center contact. Actually, ooh, look at that. Okay, let me see if I can get the camera to show that. So it looks like that center contact is quite a bit above the surface of the board. Well, that camera is not really showing it well. Let me tweak the exposure here. So if we angle it a little bit, there we go. You can kind of see maybe a bit better like this. Actually, let me tilt this a little more. There we go. You can see the center line of that center contact is quite a bit above the PCB. So that could be part of the problem. So that's one. So we got one right now that we're kind of thinking is probably the connector tipping. Again, these are difficult connectors to hand assemble because they don't fit snugly like the other ones. They fit kind of loosely on the board, and it is difficult to get them to sit right. So that's something that could be an issue. Looking more just to make sure. Again, I'm not certain that the SMA is at fault here. I don't have TDR traces showing exactly where the mismatch is yet. In the vertical axis, we'll call it, alignment looks pretty solid. I don't see significant misalignment. And then, let's see, nothing else obviously out of place here. I'm not seeing obvious damage to the connector. Let's have a look in there. So the other thing that is a little bit of note, although this is the case with I think all of these right now, is when depanelizing I did not sand them off fully. So there is a little bit of a gap right, if I can get that in focus. There is a little bit of a gap between the edge of the copper and the start of the SMA. Again, I think that's electrically short enough to not matter at 6 gigahertz, but I am not certain that that's not the problem. Okay. So that's one potential cause. All right, so that was A69018. Now we've got A69007. So this one, let's go back to the S parameters for this one. A69007. And we want to see S21. Okay, so A69007, this one fails quite a bit worse. We dip below 3 dB around 5.2 gigahertz. All right, so we dip below at 5.2 gigahertz, and there is also that big dip there that I don't think a lot of the good ones had. Let's just throw in one of the good ones for reference. Like, we'll do a 69015 as a good reference. Okay, yeah, so the good one, that's interesting. The good one actually has a bit more, maybe, ripple in this area, but we don't have that big dip right there. So that big dip seems indicative of a problem there. And again, the red one is the one that we think is, or the one that we are looking at right now that is bad. So going back to the scope view here. So the first thing of note, comparing, let's look at the other bad one we were just looking at. That was A69018. So A69018, let's go pull up the S parameters for that one. A69018. Okay, so 18 is the one that has the big gap under it because the connector is cockeyed. And that is the, let's see, let me pull up the microscope view. see if we can't see both of these at once. Okay, so A69018 is the pink trace here. And so that one is barely starting to graze our 3 dB threshold, so minus 23.5 dB. We're just starting to graze that at 5.7 gigahertz. And so this, again, this is barely failing, and yet looking at the alignment of the connector, it's way off there and the pin is way off. So it's possible that's not the biggest thing that's killing our performance. Then jumping back to A69007, which is the red trace, that one dips down way sooner. So that one has the much bigger impedance discontinuity somewhere, again, believed to be at the SMA right now, but it's got the much bigger ripple here. Let's get rid of the good one. So let's see, so blue. All right, let's change colors here just so this is a little easier to tell them apart. So A69007 has the much sharper dip at 1.8 gigahertz. And it also loses bandwidth. It appears to be maybe a little bit of a steeper drop-off, especially in the 5+ gigahertz range, because we've got the dip here. But then starting here, we're just starting to graze 3 dB at about 5.1 gigahertz. And then we've got that. It's the same ripple this one has, but it's a lot lower, so maybe it's adding on top of something else. And so we're half a dB almost beyond the acceptable threshold at 5.7 gigahertz. And so now the question is, what's wrong with this one? And again, right now I'm focusing on the SMAs. I'm not saying the SMAs are at fault. I'm just trying to compare one attribute of these probes at a time. So looking at this one, it looks like it's sitting a lot flatter. So we've got that nice gap on the underside here. So that is suggestive of the SMA being correctly aligned. Again, looking back at number A69018, we can see we've got almost no gap on the underside and a big gap up top. So this one is what I would consider correctly placed in the vertical axis. Now in the other positions, okay, all right, so we got a couple of interesting things going on here. Let's make that view a little bit larger. So there's what looks like maybe some, I don't know if that's plating or, yeah, that looks like it might be a little bit of plating on the edge of the connector kind of sitting there in the corner. That looks a little bit funky. I'm not sure if that's a problem. Then we've got what looks like maybe a little bit of a void in that via where some of the solder wicked down. And then we have sitting up top over here, we've got that little blob of solder from, I guess I was probably, when I was hand soldering the center pin, I probably brushed the iron against there and a little bit of solder stuck there. But looking at this one, again, this is 007, so this one actually has worse performance, and yet visually, if you had asked me to look at this, I would have told you it was better. So the question is, what's wrong with this one? Zooming in a little bit more, one thing that does come to mind right away is potentially there is more of a gap there between the edge of the board and the SMA. So we might be getting a little bit more of a step there. Let's see if I can get the two of these on there kind of side by side and compare. All right, let me actually grab stills of these so I can try and compare more precisely. So let's go to max magnification so that we're at a repeatable performance, and grab a still. Okay, so this first one is 007, and then this second one Same magnification. The second one is 018. So if we jump these up to the same magnification here, so we've got 7 there and 18 there. That's looking like a smaller gap. Let me see if I can measure in the microscope software here. Let's see. I usually just use this for taking pictures. I don't usually do any analysis in it. No, that's a calibrate. Alright, let's see if this works. So if I use the line tool, we're gonna kind of guesstimate a little bit. So we've got 297 there and okay, yeah, so they are being held at a little bit different angles, but that is looking like a smaller gap there. If I really want it to be reproducible, I guess what I could do is do top-down shots of both of them. Let me actually do that. Alright, so now we're at the top-down view. We can adjust the focus. Get this. Alright, now the challenge is going to be seeing, because now we've got the body of the connector in the way. Okay, let's see if I can do this live. Alright, so that's 87 pixels, roughly. It looks to the edge there. Alright, now how do I get rid of that? Alright, well, anyway, that's 87 pixels there. And then a 69018 now. It's like 120. Okay, so yeah, that is a significant difference. Wait a minute, that's weird though, because those numbers aren't adding up. I don't know if I trust that. Alright, there we go. So yeah, I'm not sure if I trust those numbers, because just looking at this, yeah, I really want to get these two side by side. Let's turn the mag all the way down. Yeah, it is hard to tell. All right, I'm gonna call this inconclusive for the moment, but I am suspecting that that gap could be part of the issue. All right, let's move on to another one. So now we've got a 69009. So this one, a 69009. Okay, so this one is very similar to 07 at the end, but up here we've got some bigger dips. We've got there's still some weirdness going on around 2 gigahertz, And then we've got a big dip here, a big dip here. Again, it looks like it's the same ripples, but they're more intense. So that's suggesting we've always got some impedance mismatch, but this is way worse. And then again, we're dipping down probably about a quarter to about a quarter of a dB. What is that? 23.7? Yeah, almost exactly a quarter of a dB down. About 5.8 gigahertz. So, let's see what's causing this. Alright, so we've got a little bit of flux residue on the side there. That shouldn't be a problem. That's a little glossiness there. Our gap on there, that looks like a good gap. So, it looks like it's flush with the PCB. I'm not seeing any weird tilting going on. I'm not seeing any obvious damage anywhere. Actually, yeah, again, back there is that little bit. Looks like it might be a chip in the plating. I mean, a bunch of these have some... It almost looks like there's... Well, I mean, we can see machining marks on the plating if we look at the right angle. You can actually kind of see the tool path where they milled out some of that. That's cool. But looking in there, so I do see a little bit of solder flux in that cavity under the center pin. There is still that gap that I'm not thrilled about, so I may consider doing a panel at some point, or at least one or two boards where I kind of sand the edge more aggressively and try and get that copper all the way to the edge. Okay, so I just saw that comment. As far as non-solder connectors, so the problem is most of those, the compression mount ones, they are significantly more expensive, and they're also a lot bigger. They need through holes to screw in place. Most of them, I think, are also perpendicular mount, which is potentially a problem as well, as far as being compared to being inline. I will definitely be considering that for higher-end probing in the future. I really want to keep these solder on, but yeah, it does look like that's one of the main sources of yield variation. Although again, I haven't started to look at the resistors, because we can see if we take a look at this one, for example. Oof. Those resistors are not exactly vertical. Let's see if we can zoom in a little more on that. So that could be part of the problem as well. I'm trying to focus on the SMAs first and see if I can correlate, because right now there's enough things that could be varying. I'm not sure. I know I did have, so the panels on these boards with the stiffener on the bottom. If I turn the mag down, the stiffener on the bottom does make it a little bit challenging to place these. Let's turn the brightness up on the microscope a little bit. So the stiffener does make it challenging to get the boards pasted, because when you look from the side, you can see there's a significant thickness variation on the board. So I did have problems on at least one of the panels. I did have problems at least one of the panels with the solder paste volume being significantly excessive. I had problems on the other panel with solder paste volume being low, so I do need to work on better process control of that for certain. And, I mean, both of these, both SMA connector and resistor, I'm seeing variation. I want to improve it, but right now I'm hoping I can find specific correlations between certain defects in the S parameters and placement issues. So let's jump back and look at the other ones and see if we can't find anything on the resistors. So this is A69018, so that's the blue trace. This is the one that barely failed. And this one that barely failed, the resistors are also topsy-turvy. So that may not be, I mean, it's not good, but it may not be what's killing them. And you can see we've got a little more flux in there. I do have some experiments I want to work on as far as ultrasonic cleaning of flux residues. Oh, that's interesting. Looking also at this one from the side. Is that some delamination maybe I'm seeing there? That could be a little bit of delamination going on there. Because looking from the top, yeah, I'm seeing a little bit of a bubble again. I mean, these probes have been soldered a few times during testing, but that one, let's see if we've... Yeah, so there is a little bit of a blister in that left area, it looks, on... The blister is on 018. Okay. So that blister might have been part of what's going on. Yes, these are impedance-controlled PCBs. However, obviously that does not mean that the assembly is perfectly controlled, and I'm fairly sure most of the variation is on the assembly. Yeah, I'm not seeing any delamination on the tip area here. Again, I mean, these are solder-in probes. I'm expecting them to deteriorate over time, but they should at least survive soldering in a few uses. So I'm not sure what happened on that one. This one is topsy-turvy. Alright, let's take a look at another one. This is A69010. Okay, so this is another of the barely failed ones. So this one also, connector looks to be solidly positioned. This one, actually, I think I sanded a little bit better because it looks like it's really, the edge of the copper is really close to board. Again, these do have tab routing, and I have to hand sand them on this edge. So there is going to be variation unless I sand to the point that I'm exposing copper, which, again, I think I'm going to try doing on the next panel. And yeah, so the camera feed is a little bit choppy. The reason for this is that at higher magnification, this is a little bit smoother probably. I'm adjusting exposure in order to get better performance, and there is a trade-off between being too dark and being too choppy. So unfortunately, there's not too much I can do about that. Around the resistors, so there is two-part epoxy. That's the bubbly stuff that you see on either side. Again, let me zoom out a bit. So the blobs on the side is two-part epoxy. That's there, staking them so that they don't go flying off when the solder melts. It's expected the solder on at least the tipmost one is going to melt during desoldering. So they're glued down to prevent that. I didn't want to put glue under them because that's where the actual resistive element is, and I don't want to be messing with impedances and stuff. So I figure gluing the sides of a flip chip resistor is less likely to be problematic. There is small amounts of trace flux residue. You'll see some little brownish stuff on there. I do have some Safe Wash Super on order from Newark. It was back ordered last time I checked. So whenever it comes in, I will try sonicating a batch in that and try and get as much flux residue off of the resistors as I can and the SMA. And see if that improves things. Anyway, so this is A69010. So this is the black trace. And that one is also a barely failure, and looking at the resistors, we can see that they're tippy as well. So the excessive solder volume is definitely not helping, but I don't think it's what's killing them. And again, the SMA on this actually looks pretty good, so it's possible that this one actually is, maybe the good SMA is making up for the poor performance of the resistors. Let's see another one. This is A69011. And again, we're only looking right now at ones that failed. So I'm going to look at some good ones for comparison in a bit. So A69011. Let's get rid of some of these other ones. I've got too many as parameters on here. Alright, so A69011, so we barely touch 3 dB at 5.2 gigahertz, and then we've got that same ripple dips down there. And then we've got quite a bit of this funkiness happening around 1.7 gigahertz. Okay, so this one, again, it also looks like the SMA is pretty flat. It also looks like I did do a decent job of sanding it as far as that. I'm not seeing any flux residue, or at least too much flux residue or anything in around the dielectric there. Looking at the resistors, they're also topsy-turvy. And then we got a little tiny stray bit of copper there. I wonder where that came from. A69014. Okay, so this one's almost the same as before, but we don't have that first ripple there. Things look a little different there, and then that last dip at 5.8 is deeper. So this one also looks pretty flat there. We've got just a little bit of excess solder coming off. Let me actually see if I can bump the gain on the camera up without turning the exposure up. Okay, let's see if that'll help with brightness. Okay, so looking here, we've got a little bit of flux residue. We've got some more mouse bites. I see some tab route residue. You can kind of see the drill marks right there. So I definitely did not sand this one that much. So we've got some inconsistencies in the dielectric right around the SMA. And then we've got, looks like just a little bit of excessive solder there. Overall, the soldering job doesn't look too bad, but yeah, this is quite the gap. So I am starting to suspect that this gap is the biggest problem. Yes, those resistors are 042s. Going back to look at the tip, this one actually has what I would consider reasonable solder volume. The resistors are lying pretty flat. They don't have giant blobs. There's a little bit of flux residue on top, and it looks like there's a tiny bit of a gap between R2 and R3. And yeah, definitely some flux residue up top. But overall, solder volume is a lot more reasonable. And yet this one actually has the bigger dip. So at least with regards to that rippling down at 5.8 gigahertz or so, I'm thinking it is the SMA and not the resistors. Let's have a look at this one. A68001. Okay, I already know what's wrong with this one. So that's the green trace. And this is a recycled SMA from a previous test. There's solder everywhere. And more importantly, if we have a look in at the SMA center pin, we can see there's a big chip in the dielectric there. I don't know how that happened, but it's there. And it looks like solder even kind of got in around the dielectric, so maybe it melted the edges of the dielectric or something. Anyway, so I don't need any failure analysis in this one. This is an oddball. This is the only one this happened to, and I know exactly what's wrong with it. Let me just turn the gain up a little more, maybe, so we can see. All right, yeah, there we go. So I know exactly what's wrong there. Then looking at the resistors, there's again slightly excessive solder volume, but not too bad. Alright, and now on to the last of the known failed ones. This is A69012. This one looks to have quite the tip going on. It's a little hard to see, but yeah, I think this one's kind of tipped a bit as well. So this is A69012, right? A69012. Okay, so this one also has, again, about the same ripple, quite a bit below, and then this previous ripple is dropping as well. So, all right, y'all, I can pull back 001 in a second. I'll see if I can angle it somewhere, maybe get additional lighting so we can see better. So this one, that also looks like, again, a pretty big gap. The tip of the SMA center pin it's making contact, but there's quite a gap there. And then looking at these resistors, they're also a little topsy-turvy. I'm kind of curious now. What I might want to do is try hand assembling one just to see if I can do better. But before we do that, let me get a brighter light, and I'll have a look in at A68001. Let me try and get this position somewhere a little bit more stable. Okay, there we go. Can you see what's up with that connector now? It looks like the whole edge of the dielectric there is melted, and there might even be some, yeah, there's solder wicking up into the cavity. So this is definitely an assembly defect. All right. So at this point, I think I've looked at all of the bad ones. Now, let's look at a few good ones and just see how they compare. So we got A69013. So this is a good one. So we've got nice big gap, lying flat. Looks like I sanded it closer. This one actually does have a little burr. Let me get that light back. So there's a little burr on the, I guess, the top side of the SMA right now. Which I haven't touched because I don't want to mess with the performance. So that's a good one. And then looking at the resistors, these are also a little bit tilted. So it's looking like the resistor tilt is not actually that big a problem. These are tilted as well. This is A69008. Okay, so we got quite the variation going on here at 3.5 gigahertz. Whoa. But they do both meet the 6 gig bandwidth spec. So looking at this one, again, we've got, it's nice and level. And there is still a pretty good gap there. A69017. So this one's got much more ripple. Again, it still is hitting the 6 gig bandwidth, but it's kind of questionable. This one, it looks like, is a bit tilted. We can see there's not as much of a gap at the bottom as there should be. This one actually also looks like it's got some weirdness in the plating around that center contact. Let's get the light in the hull again. So I'm not sure if this is happening during soldering or if they're from the factory like this. This is the first time I've looked at these connectors so closely. But if there are plating bits coming loose, then that's definitely something to pay attention to. And these are looking fairly level. All right, let's pull up the other good probes and we can compare. You wanted to see the best one? All right, let's see which one is the best. So we got A69001, 016. Wait, A69001. A69 016, 002, 003, 015, 006, 004, A68004, and A69005. All right, so as far as which is the best one, that's a little bit subjective. So are we going by what's the highest S21 at 6 gigahertz? That would be A69005, but it looks like it actually dips quite a bit down here, whereas, say, A69006 dips less, but also goes less down there. So they've all got their own little variations. I am curious about this one, A69003. That one does meet the bandwidth spec, but I am tempted to declare it failed on the basis of that giant spike at 3.5 gigahertz. That's not very flat. So looking at this one, I do see some flux residue around the connector. I'm not sure if that's problematic or not. This is no clean flux. It should be okay to leave on there. I do see some misalignment. Let's turn the gain up a little bit on the camera feed again. So I do see some misalignment. If we look top down, we can see it's the center contact is a good, I don't know, 10-20% of the length of the width off of centered. So that could be part of it. Again, the sanding of the edge there's definitely some flux residue in there. And then looking at the resistors, They're tilted, but so is everything else. Also of note is looking at the side. We also have that little blister of delamination right there. So that delam could be part of the problem as well. I actually see multiple blisters in a couple of different spots here. Okay, so now I guess the question is, what do we know for sure? So these are the good ones, and then let's pull up the bad ones in a separate plot here. So that's the good ones. These are the bad ones. So 69, 9, 10, 7, 18, 11, 12, 14, and A68001. And yes, I do try to use as little solder as possible on the center pin, but it is hard to do hand soldering, so that it is possible that is part of the mismatch. So these are the failed ones. Looking at these, we can see there's a lot more variation. And again, A68001, the green trace at the bottom, we already know that's a huge outlier because of the damaged dielectric. So the fact that all of them, even the good ones, have ripple that looks very similar, just lower amplitude, that's telling me everything has an impedance mismatch at the SMA. It's just that most of them have much less of a mismatch than that one does. But what is odd to me is just after 3 gigahertz, that one has the huge dip and all the others peak. So what I'm wondering what I'm thinking might almost make sense to do right now is if I grab another panel of these boards, if I were to just grab one board off and hand solder it and try and sand it as close as I can, trying to get the copper right up to the edge of the board, then I guess I'd probably oven reflow the resistors and then hand solder the SMA, trying to get it as precisely aligned as possible and use as little solder on the center pin as possible. And then just go throw that on the VNA right now. I think I might do that. So let me jump over to the overview. All right, yeah, I'm gonna go depanelize one of these boards right now, and we're gonna see what I can pull up. Okay, that's interesting. Is that video feed updating at all? Let me jump back in there and see. Okay, for some reason that camera is not giving me a live view. If I toggle it and restart it, it seems to give me an update, but it's not live streaming correctly. Alright, well, I guess I'm gonna have to make do. Let me jump back to the... Alright, let me get to the bench work. Okay, so there's that. That camera is working. Alright. That one's working. And then... Oh, no wonder. I was trying to get the MP4 streams of those ones. Alright, I'll have to debug that camera a little bit more. Okay, there we go. So that one's updating correctly. Okay, so yeah, I'm gonna go depanelize one of these boards, and we're gonna see what I can do just hand assembling that one as precisely as I can. I'm not gonna worry about doing the rest of the panel. I'm just gonna try and do this one. I also still have to investigate why, for some reason, the overhead cameras don't seem to want to live stream. They work fine with the security system, but for some reason, OBS doesn't seem to want to live stream from them. So I don't know if the camera can't handle 2 streams going at once on it or something. Alright, so we got one board off the panel. Let's go clean all these FR4 scraps off the bench and sand it. So that's all cut and trimmed on the edges. I just got to sand the FR4. I will try and switch to the other camera for that, and if it doesn't update, I'll be back at the bench in a minute. Alright, so we've got the board depanelized. I sanded it. Apparently not far enough. Look at that. We've microscope view. So yeah, apparently I didn't quite sand it enough. We've still got some gap between the copper and the edge of the FR4, so I guess I'm going to go back and sand it a little bit more. I'm going to leave the bench camera up and hope you see some of it. Alright, let's see what we got now. That looks more like it. So we've got copper pretty much right to the edge of the board. Let me just go clean that up a little bit. Alright, so that's cleaned up as much as I can get it. And it does look like we've got copper pretty much to the edge of the board. So now I guess the next step is going to be manually solder pasting this. Try and get... Actually, I might just iron tin the pads and then put some flux on them rather than using paste, just since it's a one-off. Do I have... Yeah, the captain tape's out on the bench. Alright, that looks good. I've got way more flux on there than I need. Let me clean some of that off. So again, the emphasis at this point is on getting minimal solder volume, very controllable volume, and see if we can eliminate some of that variance here. And then on the SMA side, Again, focus is going to be on getting the tightest alignment tolerance that we can and using as little solder as possible on the center contact. So if we drop back to the microscope view for a second, we can see that the pads are all tinned and the volume of solder is relatively low. I'm actually a little bit concerned that that might be too low on the tip, but we're going to find that out once it gets in the oven, assuming I do. Yeah, I'll use the oven for soldering these. So I guess I'll go grab the resistors and see. Let's get just a tiny dab of flux on here. We don't need a lot. Always takes a little while to start flowing. That's probably 5 times what I need, but it'll do. Okay, so we've got our one SMA we're going to be using. We've got our 50 ohm resistor, and we've got, which one of these reels at 200s is? Okay, we'll use this one. So those are the 200s. And that is what happens when you leave the double-sided tape on your fixture. And now our 50 ohm. Alright, and that is good to go. Now we can go stick this in the oven. Alright, board is in the oven, and while I'm waiting for it to cook, I guess I need to assign a serial number. So, today is the 79th day of the year, so this is going to be A79001. That will be the only probe in lot A79. So let me go print a label for that while I'm waiting. So the board is done. It's cooling down. We'll give it a couple of minutes. I will be skipping the epoxy. Unfortunately, there isn't really any way that I can do that in a timely fashion. I don't know if I've ever actually measured any of these other boards without the epoxy, so it'll be interesting to do this one with and without and see if we see any parameter shifts from adding the epoxy. While that's happening, I am going to go and calibrate the VNA, get the cables on there. I am not going to be repeating my mistake from last time, and I will be making sure everything is properly torqued, even the connector savers. Alright, so I just turned down the fan on the fume extractor. It looks like most of the smoke is out of the oven, so it should be a little bit less loud here. Alright, so next calibration, 1 short, 2 load. One short. That doesn't feel quite right. Alright, 1 short, 2 load. And we torque that one, right? Alright, next is 1 short, 2 open. Before I do that, actually, let's close that. I don't think this matters for calibration, but let me just turn off the de-embeds. Pico software is a little clunky. It wouldn't surprise me if it tries to calibrate with the de-embed still on, so I'm going to turn that off. And I am going to redo that part of the calibration. So 1 short, 2 load. Remeasure. And then 1 load, 2 short. Probably not necessary, but the software has been annoying enough for me in the past. I don't really like using it in any way other than what I know works. Alright, so that's 1 load, 2 short. Alright, now short and open. Alright, 1 open, 2 short. One open, 2 short. And then swap. Maybe my next VNA will be fancy enough to have an ecal and I won't have to do all of this. One short, 2 open. And through line. Alright, insanity check. Alright, that's looking like we expect. So we're done with the cow. Let's just cap these for a second until we're ready. And the board should be cool enough to work with now. Alright, well, I can tell you already that didn't work out quite like I planned. That resistor is not supposed to look like that. Alright, so we gotta hot air this. Great. Okay, we actually have a couple of problems here. That did not work nearly as well as it should have. That one there is not even making contact. Geesh. Alright, I am gonna have to hot air all of this. So much for a nice repeatable test. Alright, let's get a bit more flux on here. I'm gonna have to just jiggle these into place by hand with hot air. Alright, that should be enough flux for this. More than enough. Alright, that's looking a little bit nicer. Let's go get some of the flux off of this and see if everything is looking good. So again, no epoxy on here at the moment. Just trying to minimize variables. Alright, now before we do anything else, let me go grab some meter leads and just make sure we got good continuity here. So we're measuring 450.39 ohms across the resistor string, which is exactly what we expect. So that's good. Now the question is, can I get the SMA on here with a little bit more repeatability and precision than I've had in the past? Because I really think that soldering of the SMA is the main source of the problems as far as reliability. I mean, as far as bandwidth is going and impedance matching. So I'm probably going to end up having to build some kind of jig for this. It's going to be hard to do otherwise. So back to the microscope view. IPA clean, make sure we have as little foreign matter on here as possible. Use both sides of the swab for a final clean. Alright, so I'm pretty sure that should be a nice, clean, contamination-free surface. Now, the connector has to be sitting right there as stably as we can get it. So I'm going to try that same little thing with the adapter that I had before temporarily just to hold it in place. So that actually seems to be pretty stable as long as I pinch it. Crazy idea. What if I use a second stick vise to pinch this together? So yeah, this might be a little bit of a crazy idea. It's not quite big enough. Okay. Or is it? It might be. Okay, this is ridiculous. But it just might be crazy enough to work. Okay, so let's see what this does. Okay, no. That is not, I don't think, stable enough. Let's see. That's actually fitting pretty snug. I can't get a knife blade under it. Let's see if I can do it from a shallower angle. So I can get the blade under from that side. So the connector is slightly rotated, it seems. Which makes sense because of that. Alright, well, this is the most stable connection that I've had during soldering yet. So I think I'm going to try, and I'm going to see if I can get this to work. Alright, that looks to be solidly tacked down. Let's tack the other corner, and then we'll take this jig away and see if this is actually where I want it to be before I secure it more completely. And then maybe a little tack at this side as well. Alright. Moment of truth. Dismantle this ridiculous ensemble and see what happens. So the question is, how precisely aligned is the connector right now? That's looking solid. It is just about dead on that side, and yeah, it's pretty much flush. I don't think I could do better. And vertically, that's right where I want it. Alright. Now if I can just get this to stay put as I fully solder it, I should be okay. This is definitely the most precisely positioned connector I've done to date. So if this jig idea is worth it. Alright, that looks good. Now other side. That's looking good too. Now for the tricky part, the center contact. I'm going to try and get as... Actually, before I do anything else, let's just... That's looking pretty tangent. I think it's right where I want it to be. So now let's just see how little solder I can get away with using for this. I think that's enough. Let's just make sure it's melted all the way back, and good. Alright, I think that's good. Let's clean it and see what the VNA has to say. Alright, that's looking good. It's centered. There's not a huge amount of solder on there. We've got pretty much, I don't know about zero gap, but very close to zero gap there. Probably just defined by tolerances in the connector. Looking at the connector around the mating surface, I don't see any obvious plating damage or anything like we had seen on some of the other ones. So this looks like a solid connector. And then looking at the resistors, the alignment is pretty accurate. Our resistance measurement checked out good. There's not excessive solder. They're not wobbling or anything like that. So I think at this point, this is about the best I can do. So now the question is, what happens when I stick it on the test fixture? So I do need to start with, what is it, 13.2 millimeter de-embed, or reference plane extension. Alright. So we had a de-embed on port 1 of the fixture, and I think it was 13.2 millimeters on the reference plane. We're going to see how close that gets us. And I had some double-sided tape that I must have put away somewhere. Let me see where that went. Alright, so I will have to be careful when I take this probe off of the fixture because the resistors are not glued down and I don't want to fling them off. So I will have to use care on that. I may actually epoxy it while it's still on the fixture just to avoid that. But that's going to be a problem for another time. Alright, I think that's soldered completely. So, fingers crossed, we've got the tightest tolerance prototype yet on the fixture. And we're about to see how it performs. Get all of the flux that I can off of the tip area. Oh, and before I forget, I need to flip this whole thing over carefully and stick the serial number label on there so I don't mix this up with any of the other prototypes. So this is A79001, and that goes right there. Okay, let's see what happens. So port 1 is the fixture. This is A79. Port 1 is the fixture. Get that roughly where we want. And backing wrench and torque. And now port number 2 to the other end. And back. And torque. Alright, and let's just hold that, keep it from moving, and jump over to our VNA. Alright, we got our data. Let me just disconnect this. I don't like leaving the VNA cables on longer than necessary just because they can put force on the probe, and this is a temporary test setup. I didn't tape everything down and so on. Okay, so let's move our test setup out of the way. And just to confirm, this is A79001. So let's save this. A79001, debug refixed, and we don't need our soldering stuff on anymore. Let me flip that off. And the moment of truth. A79001, and we want to see S21. Well, so I don't think this is worse than the other ones. I mean, this is definitely a 6 gigahertz probe. I would use this as is, but I also don't know if it's better than what we've had before. If I pull up some of the other ones, like A69, 2, and 16, just for reference. So I don't know if it's any better. Let's see. So A69-2 has that big hump. Let's delete that. Let's just do 16 for comparison. So it does look like maybe around 2 gigahertz that dip there is a little bit less. And the dip there is a little bit sharper, but the overall ripple doesn't really seem to be changed much. So maybe it's not connector soldering tolerances. I mean, again, this one probe, it doesn't seem worse than any of the others, but I don't know if this extra effort in assembly really paid off at all. Although I guess the other question is, if I hadn't done this, would it be more like one of the bad ones? Because actually this new one actually even has slightly worse ripple around, what is this, like 4.2 gigahertz. The ripple is actually a little bit worse. Which, I mean, is probably just randomness, but yeah, I don't know. I'm not convinced this is an improvement. Let's go and pull up a few other ones. Actually, let me desolder this one and let's just have a closer look at it. I think I am going to desolder it. Which is always a exciting moment with these probes, especially if they're not glued. I usually need hot air to get these off, so let's see if I can do this without. Yeah, okay, no, this is not coming off without hot air. The thermal mass of that is just too high. Alright, well that came off nicely. Yeah, I would really like to design a test fixture that has less of a thermal mass problem for exactly this reason. You know, the other thing I haven't explored yet is repeatability of the probes. If I take it off and put it back on, how likely am I to get near identical response? Let me take this one off just because it's not glued. I don't want to use that again. So let's get one of the other probes. Let's do A69-016 I was just looking at. So let's see what happens if I put that one back on the fixture. See how close it gets to the response I had before. Because if it turns out that a lot of my variation is coming from the soldering of the tip, then we'll have problems, because it means that this test would not actually be representative of the probe's performance. Alright, so this is A69016, and we're going to do it a second time. Alright, so that's cleaned up. Now we got port 1. Oh, and I put away that. So port 1 onto the fixture. I'm very curious how repeatable these are going to be. Because if it turns out that it's not as repeatable as I want, yeah. Yeah, especially if we get like more than maybe a 0.1 dB shift or something. Alright, so that's port 1, and now this is port 2. So the other thing I've noticed is there is fairly significant variation in S11 from probe to probe. I don't know if that's soldering variance or something else. But I guess we're going to find out, won't we? Alright, so take the VNA off. Okay. So now let's add our resoldered Well, uh, okay. This is the same probe. That's interesting to say the least. The resoldered measurement of this same probe actually fails it. It dipped below 3 dB there. So as this probe stands on the fixture right now, I would have marked it as a fail. So that suggests that the margin of uncertainty in these measurements is not as tight as I wanted. So maybe I almost wonder if repeatability of the test fixture is now the problem. I'm just looking now at the board on the fixture. Yeah, this is not good. I mean, actually, I mean, it was fairly close down there. The actual variance there is only 53.36 to 0.53. It is only 0.17 dB. So it's not that bad, but still, it makes me question whether some of the probes that I'm failing are just not quite soldered right. These might all be 6 gigahertz probes if soldered correctly. And I guess on the flip side, the question is, yeah. I don't like this fixture not being this repeatable. Especially around 2 gigahertz, there's still that big thing there. Which I am beginning to wonder if that is a, because let's look at the S11s. Yeah, so there is S11 variation too. So the resoldered version actually is a better impedance match to 50 ohms than the original was. And again, same probe. Does group delay show anything? Okay, no, group delay is basically unchanged. Let's see if phase is looking any different. S21 phase angle is it's within one sample of the same phase. So, yeah, a fraction of a degree phase match. Even at 6 gigahertz. At the same point. Yeah, so it's still half a degree phase matched. So that's not the problem. So why is our S21 magnitude so variable? Everything was torqued the same. It's the same probe on the same fixture. It has to be the launch when it was soldered. So there must be more variation in the launch than I expected. And no, wait, I don't want magnitude, I want dB here. I'm going to desolder this, take it off. I'm starting to wonder now about the ones that barely failed, if maybe I should just resolder them and maybe they'll pass. Because if I can improve my yield, that's a good thing, but on the other hand, I want these probes to perform well repeatably. Alright, so that's A69016 is now off the board. And so I'm still going to put this one back in the passing pile, even though I would have marked it failed off of these S parameters. And this does also call into question the validity of having per unit de-embedding curves if I can have variability that's this significant. I mean, again, the peaks are in the same spots, but especially there's spots where the difference is like 0.2 dB from one to another. So I guess the question is it even worth having the per unit calibration option when it seems like the unit-to-unit spread is in large part due to the soldering, and that's not really going to be easy to calibrate out in the end user's final application. Alright, so let's go back here. Let's find some of the failed ones. That barely failed. So alright, let's try this again. Alright, this one, A69018. A69018. We're going to put this back on the fixture, and we're going to compare before and after. Oh, and then I guess another variable I'm not considering is the mating and unmating of the VNA cables on the fixture. These are reasonably phase-stable cables, but there is always a possibility. I should actually do that. I should remeasure just after jiggling the cables and putting them back on and see how repeatable that is. Because obviously I don't want to be soldering to the fixture while it's on the VNA, but... Alright, so this is A69 018. Alright, let's just triple check. This is 18. That's quite the shift. But... yeah, it's subtle, but... there's a difference down there. And more importantly, this new measurement is showing this probe is passing. So I'm going to put this in the passing pile. I think it just might have been a bad solder job. So this is starting to suggest that anything that I fail by a small margin needs to be resoldered and then tested again. So much for repeatability. I mean, there is always going to be some variation to the solder and probe. I was hoping it wasn't going to be this bad. Let me just desolder this one real quick. Well, I salvaged one of the bad ones, so my yield might not be as bad as I thought. I might just have to work on really consistent soldering technique. on the fixture. I was thinking of designing a new fixture for the next round of boards anyway, because I want to be able to, I mean, this fixture you can tell is wearing out, but I want to be able to have the probes come in straight on. I don't want to have quite so much copper on the fixture, because obviously I need a lot of heat and hot air pain trying to get the probes off of here. So what I might do, I might retest over the next couple days. I might retest all of the ones that failed by a small margin. And then, alright, so A79001. Okay, so that is a pass. But I'm putting it separately because it needs to be glued. So what I might do is, yeah, I'm going to retest the ones that failed by a small margin, see if they pass with a second soldering job. So every probe is going to get 2 tries. If they solder correctly, if they perform better when soldered correctly, then that will definitely help as far as improving yield. But I'm still not thrilled with the repeatability, and I'm not sure what I can do about that short of, again, designing a better fixture. So I guess that might be the next project, is designing a fixture that, because right now I just kind of eye the placement on here. So if I were to design a fixture that maybe instead of a coplanar waveguide, maybe if I used a microstrip and I had a defined test point I could solder to, it would probably be easier to desolder because of the... It would be easier to desolder because of the lower thermal mass. It would probably be better for the probes as well, just not being heated up quite so much so often. And yeah, that's probably gonna be the way to go. I guess I'll have to design a transition from coplanar waveguide into microstrip for that test, but I mean that really needed to happen anyway. I guess that's going to be the project then. I'm not sure there's too much else I can do tonight then. I mean, I guess that kind of answers the question. Is the majority of my variability now is coming from soldering variation. And yes, there are some that are obviously way off that are not going to be usable, but when I've got 2 probes that, again, have 0.2 dB variation for the same probe and the same fixture soldered a little differently, I guess I just have to work on being more consistent with that. Well, I guess that's about it for tonight, so thanks for anybody still watching, and I'll be back another time.